Your favorite thing and mine, money. These are problems that usually really motivate students into finding the importance of the mathematics we study. Someday, some of you are going to open businesses and do some amazing things, and math is definitely going to play a role, maybe more than you understand now, but these problems are pretty cool, and I think you'll find them interesting. One of the things that you want to think about, especially because we've spent some quality time studying parabolas, is that what goes up must come down, right? We have these parabolas that we see from time to time. And why I take some time to explain this to you is because we will see this shape when it comes to money. For instance, if we raise the price over time, what we can also expect to see in some regard is a decrease in the number of items we sell. Conversely, if we reduce the price, we could see an increase in the number of items that we sell. It's that whole idea of supply and demand. And that's kind of what we're taking a look at in, for instance, a problem like number 5. So here's our go-kart problem. We have a go-kart track, has about 380 racers per week, and charges each racer $35 to race. So if they did nothing with their price, we could take a look at our original revenue. Revenue, again, is the money a business brings in. Original revenue in this case, if we have 380 racers per week and they charge $35 per racer, we would get our original amount of revenue, which would be, initially, was it $13,300. So if you give that some thought, what we're going to postulate in the next couple of sentences is if we knock some money off the price, we could actually get more racers to show up and actually raise the amount of money our business makes. So it's a quadratic model in that regard. So the owner, and I'm just reading along, the owner estimates that there will be 20 more racers per week for every $1 reduction in the price per racer. We're asked, how exactly can the owner of the go-kart track maximize their weekly revenue? So I basically just took some time now to write down some things that I know about the problem. And what I'm hoping you pulled out of that first line that I wrote there is that we have a formula. Revenue, the money our business brings in, is always going to be found by multiplying two things together. In this case, the revenue is found by multiplying the number of racers. And other problems, it could be a number of products or a number of, people. So a number of racers times the amount paid by each racer, the amount of money paid by each racer. That's how we're going to calculate the revenue, the amount of money, again, the business brings in. Not the same as profit. Don't confuse those two topics. So the amount paid by each racer. Okay. So now what's going to happen is we're going to tweak our revenue, hopefully maximize, right? There's that word, maximize our revenue by tweaking our number of racers and the amount paid by each racer. And we'll write the revenue as a function of X. And you're probably saying, well, Mrs. Lucas, what's X? X in this case is just going to be the number of times we reduce the price. That's usually what it is. Number of times we have to reduce the price. Sometimes it's it says per week, so we could even do it as a number of weeks because we're going to reduce the price each week. So you could do a number of times we reduce the price. It could be a number of weeks. There's a couple of different ways to look at this. So the number of times we reduce the price. You could even call it the number of price reductions. There's more than one correct way to state what we don't know in this problem. So in this case, let's look at the number of racers. If I start with 380, and we hope to add to the number of people, right? We're going to increase the participation at this go-kart track. They're estimating that we would get 20 more racers per week for every $1 reduction in the price. So every time we reduce the price, I get 20 more racers. So if I reduce the price by $1, I get 20 more racers. If I reduce the price by $2, I get 40 more racers. If I get the price knocked down 3 times, I would have 60 more racers. So this is telling me I'm going to add on a multiple of 20. I'm going to add on 20x. Now this only happens if I reduce the price. So the original price per racer, if you'll recall, was $35. But I have to take money off. So I have to subtract now the dollar price reductions. So I could, after 1 week, I hope to reduce the price $1. 2 weeks would be $2. 3 weeks would be $3. So really here, because it says we're going to reduce the price $1 per racer, we could say that's 1x. See that? That's 2 binomials multiplied together. That's going to make us a nice shiny quadratic. So if I FOIL this, go ahead and make this black again. First outers, inners, last. I can write this quadratic in standard form. I get negative 20x squared plus 320x. Because if you do negative 380, plus 700x, that gets us that 320x plus our 13,300. So that's just me taking a second to FOIL that binomial there, or the product of those 2 binomials. All right, so now we have an equation in standard form. If you take a look, what I need to now go ahead and do is take a few moments to find the maximum of this particular quadratic. So I'm going to go ahead and find the maximum, aka the vertex, of this particular parabola. And remember, to find the vertex, we first have to find the axis of symmetry. The formula for the axis of symmetry is negative b over 2a. So in this case, that'll be negative 320, because my b value is 320, over 2 times negative 20. So my x value in this case is 8. In other words, I need to knock the price down 8 times. So I need to take $8 off the price. Now to figure out what the actual maximum value is, I need to now find r of 8. So I'm just going to take my function, 380 plus 20, and I'm going to plug in that value of 8 into my equation. So I'm taking 8 and I'm just plugging it in where I see x. So I have 8 goes here, and then 35 minus 1x. So I'd have to, again, plug in 8 there. And then I just do my order of operations. So 20 times 8 plus 380, and then 35 minus 8, multiply those 2 numbers together, and I get 14,580. So now, to wrap this up, what I can go ahead and do is write a sentence. We would essentially, and I can tell you what that sentence would be, the owner would reach a maximum revenue of $14,580 by reducing the cost to $27 per racer. In other words, taking $8 off per racer. 35 minus 8 is $27. So you just want to make sure you grab a sentence to answer the question. I did want to let you know that you could take a second to go into your calculator and verify this. So I did take a few minutes to type that equation in, and you see that there. When you press graph, you're going to again hit zoom and fit, zoom 0. And then we would go ahead and calculate that maximum value by pressing second, calc. We want to go to option 4. And we're going to go to the left of that point. And then we need to go to the right of that point. So we need to go to a number bigger than 8. And press enter and enter again. And you see that I do hit my maximum when x is 8. So reducing the price 8 times. I get that maximum revenue of $14,580. So if you look at the problem, we started with the $13,300, but now we ended up with the $14,850. So we did actually increase that price. Pretty cool.